Okay, good morning. Welcome to
KidMath93.
KidMath93. Yesterday we started in one of the optional chapters in the algebra book. Has a star on it, and it's about quadratic optimization. But it's a really cool idea, and it's sort of almost kind of the next level up ideas in math. So I thought it'd be fun to just talk about it a little bit. And let's see if we can go through an example real quick. Find the minimum point on the graph of y equals x squared plus 4x plus 11. Do you understand the problem?
Yeah.
All right, did we bring an eraser? Why do we always forget erasers here? There's a sock right here. It's fine. Sock eraser. What can you tell me about this graph?
Well, it won't be an upside down parabola.
No, it won't. It won't be an upside down parabola. It also won't be a banana. What will it be?
It might be something like this.
Okay, it looks like it's a parabola pointing up. So it does have a minimum point. And how do you know this is a parabola that's pointing up?
Because the x coefficient isn't negative.
Which
the x squared coefficient.
The x coefficient. 1. Okay. Good. Good. And we don't know what it's going to look like. It might not look exactly like that, but it's going to be a parabola that's pointing up, and that helps us understand at least why it has a minimum. Okay, how would you like to approach solving the problem?
Let's do completing the square.
Okay.
To get.
Let me sock erase this for you.
Alright, so we have the product of the roots is 11, and the sum is 4. It's negative 4.
Okay, so first you're going to try to factor it?
Yeah,
okay.
But this doesn't seem to work because 11 is prime.
Yeah, it doesn't seem like it's going to factor, at least not over the integers. So.
Yeah, maybe the roots are going to be imaginary.
Huh?
We could try the quadratic formula to find out.
Alright, you want me to write?
Sure. Minus b.
Minus 4.
Yeah, plus or minus the square root of 16. Minus 4. It's minus 44. Over 2.
Okay. These are the roots. Without even doing the rest of the math, what can you tell me?
These roots are going to be imaginary because this is going to be a negative square root.
Right, the roots are imaginary. Because 16 minus 44 is negative. Okay.
So they're not. It's not going to be touching the x-axis.
Right, right.
So what can we do?
Yeah, what can we do?
Well, we could do x squared plus 4x plus 4. That's a square.
Okay, so this equals x squared plus 4x plus 4.
And then you can do minus 4 plus 11.
Okay, which is going to be what?
It's 7.
Okay, plus 7. So this equals x squared plus 4x plus 4 plus 7.
Which is x plus 2 squared plus 7.
Plus 7. So that was actually your first idea to do completing the square.
Yeah.
So that's awesome. So what does that tell us? This gives us a little bit more. Let me just draw on some grid points for you. Except I picked it too high. Here's 7.
Okay.
What's this going to look like?
This shifts it up 7.
Yeah.
This shifts it over this way too.
Right.
So it's going to be somewhere like this, kind of.
Okay, can you be even more precise than that? Where is the minimum point going to be?
The minimum point is where y equals 7.
Okay. And what does x equal at the minimum point?
X equals negative 2.
Okay. So where is that point?
That would be here.
Okay. Right where I drew the 7, helpfully. Okay. Great.
So...
Yeah, so we got a parabola that sort of looks like that. And the minimum point is x equals minus 2. Y equals 7.
Awesome.
Okay. And this is a fun part of math. Now you're actually investigating points on the curve, and you're able to find a minimum point, at least for a quadratic. And finding these minimum points and maximum points becomes a very important part of math, and largely, at least what about half of calculus is about. So it's a fun topic. All right, good job, sweetie. We'll do some more examples later today.